All right, so now we're going to get into a couple of word problems that utilize exponential functions. But before you freak out, I do want to tell you that these couple examples, the next couple, are like the easiest word problems that we're going to deal with, period. They're really just plug and chug type of problems. There's a couple little caveats you got to be careful of. But let's go ahead and read through this one. The size of the rat population of a wharf area grows at a rate of 8% monthly. If there are 200 rats in January, find how many rats, round to the nearest whole, because we don't want portions of a rat, should we expect by next January? And use the equation 200 times 2.7 to the 0.08t. Now, the one thing I just got to tell you about equations that come with these exponential functions is the big thing we got to be careful of is to make sure that our units match up. That when we're talking about a monthly rate, then the time that we plug in needs to match up. It needs to be that many months. So if we're going January to January, that's 1 year, that's 12 months. So what this problem is really asking us is when your t value is 12, how many rats do we have? And so really this is as simple as saying y equals 200 times 2.7 to the power of 0.08 times 12. Notice that the right-hand side is all numbers. There's nothing to solve. It's just plug this into the calculator. So like I was saying, these really are going to be some of the easiest word problems that we ever deal with. So let me go ahead and get our calculator out, and let's take a look. So to type this into our multi-view calculator, we have 200 times 2.7. And this is where we really start to see the beauty of the multi-view calculator, is that when I raise to the power, I don't need fancy parentheses or anything. I'm just going to say 0.08 times 12. I can clearly see that it's all in the exponent, so the calculator is understanding the same thing as what I'm trying to type in. I hit enter and I get this answer of 518.966. So it's up to you on how you write your answer. I would actually accept on this 519 rats. I would accept 518 rats as an answer. 519 is probably better. The reason I would accept 518 is because I could see the reasoning that we haven't achieved our 519th rat yet. And so there are still 518 whole rats. Maybe it was born premature, we don't know. So maybe we have the 519th. But I would go ahead and probably say 519, but I would accept 518 as well. But it's as simple as that. Just plug in the numbers and go. Now, I do want to point out that if we're using the graphing calculator or any other similar calculator to this, let me go ahead and just get it a little bit better on the screen. So if we want to type this in here where we have 200 times 2.7 to the power of, so this calculator is actually doing the power in the same way. Let me change the mode real quick just so that some people don't have this math print mode in their graphing calculator. So let me just point out what it's going to look like there. So if we have 200 times 2.7 to the power of, at this point, we do not want to say 0.08 times 12, and I want to point out why. So what I have typed is incorrect, just to be clear. And hopefully it's clear when we get this answer of 2,600, but basically that, whoa, hold on a second. That's a ridiculous number of rats when we were only getting 8% more each time. The problem here is with parentheses. If we want to say 0.08 times 12 is all in the parentheses at the same time, or sorry, in the exponent at the same time, then when we hit our exponent button, we need parentheses to say 0.08 times 12 is all in the exponent. We use parentheses to say all in the exponent, and that's how we get the correct answer there.